All right, so in this last video, we're going to talk about how these things can be phrased in terms of other applications. So we're doing 24 and 26 from the book. Let's kind of go through this together. So in certain professions, the average annual income has been rising at an increasing rate. That means two things, all right? Rising, right? That means the positive slope, right? It is increasing. When it says rising at an increasing rate, that means the slope is also rising. All right, that means concave up. So rising means positive slope, increasing rate means concave up. All right, so what else is going on? So let f of t denote the average annual income at year t and sketch a graph. So really all this problem is asking us to do, in all of these words, all it wants us to do is sketch a graph of something that is rising, positive slope, at an increasing rate, concave up. So something that's concave up, kind of like a parabola, and increasing. So what we're going to do over here is we are going to attempt to do so. So here, this is our t-axis, and this is our f of t-axis. So we just need to come up with something that's going up and is also concave up. So for example, this is not an acceptable answer. Because even though it's growing over here, this is concave down. This looks like a downwards parabola. So it needs to be growing like this, upwards parabola. So this right here, this is a perfectly good answer. Okay? We don't need numbers or anything, just wants a shape. It wants something that's rising. Yep, this is going up everywhere. At an increasing rate. Is this concave up? Yep, it's concave up. It looks like a parabola. That's going up. Another way to see that it's concave up is look at these tangent lines. Hopefully you can tell green and blue apart really well. These tangent lines are getting steeper. The slope is increasing. That's another way of saying concave up. All right. Might be easier to see it with yellow. Slope here, kind of small. Slope's getting bigger. Slope's getting bigger. Concave up. That's all this problem is asking us to do. Now I hope you're ready to read because we have the next problem. So we're going to look at some cost function. All right. C of x is denoting the total cost of manufacturing x units of some product. All right. So this is an increasing function for all x. All right. If we have a cost function, it should be increasing. It should cost more money to produce things than it does to produce less. There are very few times when the actual cost of producing something new is going to make your total cost go down. Now, your profit might go up, but the actual cost per unit is still going to be an increasing function. So it's also going to provide some context on what's happening with the shape. So first off, we know it's increasing. Let's start over here. Next, for small values of x, the rate of increase of the cost function decreases. So what does this mean? Because it kind of looks weird. For small values of x, the rate of increase decreases. Kind of sounds backwards. Rate of increase, that's the slope right here, right? Okay, this is like the slope. And it's decreasing, that means concave down. If the slope decreases, that's concave down. This is so hard to read. Hopefully you can hear me. All right, and I have to actually delete this because we need to continue. We need to keep reading the problem. I got a little carried away. All right, so there's some information there to unpack as well. So it's always increasing, but for small values of x, it's concave down, and maybe that's because eventually we have mass production that's going to be coming into play. All right, so eventually, however, for large values of x, the cost is going to increase at an increasing rate. Underline that, it's important. Increasing at an increasing rate. The slope increases, concave up. All right. And maybe this is when production facilities are strained. So let's combine all the information of these blue lines. So first blue line up here says increasing function for all x, right? So that means f of x, or not f of x, sorry, c of x is always increasing. Second thing, the slope decreases for small x. So for small x, we're concave down. So small x is concave down. And then likewise, later on, we said if we have a big X, that's going to be concave up. We just need to draw this information. We're going to go over here to our graph. Whoa, that is not straight. We're going to go over here to our graph. And again, this x-axis will be how many units we're producing, and the y-axis is going to be our cost. So it always needs to be going up, and it's going to start off as concave down. It's going to end with concave up. So remember, it's going to start off concave down. That's like a downwards parabola. But this is not a good graph, because this is not always increasing, right? This is going down right here. So let's just do the start. Concave down, it's like a downwards parabola. And it's always increasing, so maybe it doesn't increase by as much, but it's still going up. But eventually, if x gets big enough, it starts looking like an upwards parabola. It starts opening up like this, kind of like a cubic function. A lot of times we will model cost functions with cubic functions. So this is a function that's always increasing. It's always going up. All right? And it is concave down in this region. And it is concave up in this region. So that's our graph. And that's our answer for how to approach these problems. All right? Again, there are more like these, so let me know if you get stuck on the homework problems. Bye-bye.